Right. Hello, everyone. How are we doing today? Well, not great considering we're all sitting here listening to me talk about linear equations. Speaking of which, you need to factorize linear equations. Sorry, you need to learn linear equations and also factorization. I'm your guy. Let me give you some tips and tricks. All right, guys. So linear equations, three basic forms. All right, y is equal to mx plus c. Forgive this. Anyway, mx plus c, where m and c are usually constants and y and x are variables. Considering it's a graph function, which it usually is, right? So basically, here's the thing: c and m stand for different things on the graph. C is basically used for your y-intercept, in this case, this point, meaning where the line that this function represents, or this function represents a line. It C represents where that line intersects the y-axis in a graph. M is the gradient of that line, increasing, decreasing, and stuff like that. Positive M means that your line is sloping upwards, negative, the opposite, right? Very simple. Simplest thing in existence. But um, let's say that you need to work out a problem with these things. You probably won't get them in this form because this form is generally actually only used for graphical for graphs and graphical interactions of any sort. Oh my god, yeah, that's embarrassing. Yeah, I'm using a wet whiteboard today because yeah, I just thought I'd try it out because paint sucks. Not gonna lie. But anyway, the form that you'll usually get questions is ax plus by is equal to c, or ax plus by plus c is equal to 0. Now, yeah, now let me explain these real quick. What's going on here is uh, there are two different variables in linear equations. There, and their powers are always, to the power of 1. They're always raised to the power of 1. Anything above that, and it's a quadratic or cubic equation, not a linear one. But today we're only dealing with linears, for all intents and purposes, you'll be using these for most of your schooling, I think, up until like 8th grade and 9th grade. Then you get to quadratics in 10th, at least in the IGCSE curriculum. But anyway, now we all know these. They're very simple. Y and X are variables, A, B, and C are constants. Uh, but yeah, this is just a basic rundown of what these equations are. Now, if you want to solve one of these equations, what you'd have to do is, let me just real quick. Nope, show me the eraser. Where's the eraser tool? There we go. That's the highlighter tool, not the eraser tool. Anyway, let me erase that. And let me give you an example. If you want to do this, what you'd have probably on your hands is like 10x plus 4y is equal to let's say 10. Now how are you going to solve this? This is a two-variable equation. Lucky for you, until like 9th or 10th grade, you don't get two-variable equations. In this case, the answer would be an expression, quite simply speaking. It would depend on whether you have to solve for x or y, but let's just say we're solving for x, in which case you'd have something along the lines of 10x is equal to 10 minus 4y, at which point you get the value of x by dividing the whole other side by 10, which is approximately, yeah, oh my god, it didn't shut off. Anyway, so at which point you get 1 minus 0.4y. So yeah, that's how you'd solve for x. You know the value of x in this case. But in most cases, you're not going to have both variables here. You only get an expression, like I said, so there's literally no point. In most cases, x or y, in this case, I'll take y for simplicity, will be given. So let's just assume that something into y is equal to 4. So I know that 10x plus 4 is equal to 10. Wow. So now, by the law of transposition, I'll move this side. And I'll get 10x is equal to 10 minus 4, which is equal to 6. And now to find the value of x, again by the law of transposition, x is equal to 6 upon 10, which is 0.6. Simple. Simple and easy. So simple as that. Now, in case you don't know the law of transposition, I'll explain that and another law right now. The law of transposition states that when an additive or any number as such is transposed or moved to the other side of the equality, its sign is reversed. If it's positive, it will become negative. If it's negative, it will become positive. But only in places where you're adding. In places where you're multiplying, which, by the way, before you multiply, you have to transpose everything else to the other side of the equation. Uh, Before you can transpose a coefficient, that is. Coefficient is a multiplier, by the way. But yeah, before you can do anything like that, when you transpose a multiplier, it becomes a quotient. And when you transpose a quotient, sorry, not a quotient, what am I doing? Anyway, point is, it divides instead. I keep on forgetting the names. Anyway, really simple. Nothing much to it. But then here is the law of distribution. Now, this one's a real pain in the bum. Because, yeah, it doesn't just apply to numbers, which is the example I'm about to show you. Let's say 10x plus 4 is given to you. That is not 10x plus 4. That is 10 into x plus 10 into 4. Because anything in brackets, anything multiplied by brackets or anything divided by brackets, well, the brackets are, the values within the brackets are considered as one whole term. So basically, it's like saying 10 is multiplied by both x and 4. So you get 10x plus 40, not 10x plus 4. But this also applies for anything else in brackets. So, let's just say you have something like uh, 11 plus x, or just, give me a sec. X plus 11. We'll write x plus 11 because then I'll have to explain that, right? Anyway, x plus 10 into x plus 11. How are you going to solve this? In this case, they're both treated as one term. So that means x will be multiplied by x and 11, but 10 will also be multiplied by x and 11 and will be added together. This might sound complicated, but what you'll get here is x squared plus 11x plus 10x plus 110. Yeah, tedious, and that's x squared plus 21x plus 110. That is how you use a log distribution to unsimplify something or solve a question, evaluate, if you will. But as always, life is not, it's complicated. This entire thing looks complicated, but it's not. You see, where I live, we use something known as identities. We memorize forms of these equations to do them quicker because speed is prioritized in our school. In this particular case, I'll be using I used an identity to solve that quickly. I already knew the value before I even wrote the question by using the identity x plus a, which is an integer, into x plus b is equal to x squared plus x plus b, a plus b x whole multiplied by x plus a plus ab. Yeah, and as you saw, that's completely true because let me just solve it with you. X squared, like I said, plus 10 plus 11x plus 110, which is equal to x squared plus 21x plus 110. Much simpler, much easier. Sure, you have to memorize them, and in the beginning it's a pain, but eventually you get used to it and you use them in daily life. You gotta practice. It's not Math is nothing but practice. Once you've understood a concept, you've just gotta practice it and practice it and practice it, and eventually it'll become ingrained in your blood. Simple as that. But now on to the main part of the video, factorization. Now what I just showed you was evaluating of something. Now I'm gonna show you how to reverse that process and you know factorize something, return it to its original factors. For factorization, we'll take the same example, but I'll take the value that we got. So plus 21x plus, I don't know, what was it? 110? Yeah, 110. I need to factorize this. What do I do? Uh, it's actually quite simple. Again, where I live, there's a very simple technique of doing this. That's not very technical, again. And yes, it's a little memory based, but what you do is you have to split this. I know it seems illogical, but you have to split the coefficient of x in such a way that when it's multiplied together, it forms 110. But you have to do so while splitting x into two different values that, when added together, are equivalent to this value. Let me do this in front of you just for simplicity. So I have x squared. I'm going to split this into 10x and 11x. That add together the 21x, but when I multiply 10 and 11, it's 110. And I'll right here. Now what we aim to do with this activity is very simply uh, to turn them into their original bracket state. Now how do I do that? What I want to do here is I want to get two similar values that I can take common in order to find an ends, just to simplify the equation a little bit more. So to do so, I'll put x plus 10 in brackets. Why did I do that? How did I do that? More like, I remove the x here because distributive law, and we have x squared, again, distributive law. Now, what I'm going to do here is, again, very simple. Add 11 and x plus 10, right? Because it still evaluates to the same things. But Yeah, it's still a value, it's still the same thing. But now x plus 10 is common. It's the same thing. So I can take these two values common, and instead of multiplying it two separate times and adding it all together, I just go x plus 11 in brackets plus x plus 10. So what you do is you use your factors to really just simplify the entire thing, break it down into its original composition. So yeah, that sums up your factorization. Happy mathing, people. Happy mathing.